Joining us to discuss an off-Earth manufacturing base for the Spacefaring Society, please welcome Founder and Chief Executive Officer at Besxar, Ashley Pilipiszyn.
All right. Hello, everybody. My name is Ashley Pilipiszyn. I'm the founder and CEO of Besxar Space Industries. Besxar is an American semiconductor manufacturer that leverages the environment of space to rapidly and cost-effectively produce higher performance, more energy-efficient compound semiconductor materials like gallium nitride, indium phosphate, and many others to meet future performance demands and scale. So today, you have two options. You can either have standard performance and long life, or you can have high performance and a short life. If you are a data center, if you build power electronics, or you buy for defense, what you actually want is high performance and a long life. But guess what? You can't get that today. And this really boils down to the issues with the physical manufacturing limits that we have on Earth today. So, how are we going to break through this wall? By growing the wafers where the physics already works, space. Now, before I continue, I'm imagining many of you right now have this image of a giant TSMC fab and how we're going to ship that up into space. So I'm going to stop you right there, take that image, throw it away. It's not what's happening. What I'm asking you is actually to envision what it would look like if you were able to delete parts from a fab. What if you didn't need that billion-dollar vacuum pump anymore? What if you actually were able to optimize for the materials that you were manufacturing and maximize that production output in a different form factor than you know today? So, how are we going to do this in space? Well, we're going to leverage the ultra-high vacuum and microgravity environment actually as a manufacturing input and capability. This is what unlocks higher performance wafers than what is currently available on the market, and furthermore unlocks this longer lifetime for devices. Our end state and final product that we're working towards is 8-inch freestanding gallium nitride wafers. So who's going to buy it? And before we get to that, we're really going to actually focus on, well, why does this matter? Because it breaks the performance longevity trade-off that I was talking about before. What happens here is actually leveraging the ultra-high vacuum and microgravity of space results in lower defects, larger diameter substrates, and a strengthened supply chain. So, as a substrate supplier, who's going to buy? Well, we know that there is increasing demand for GaN in general, but increasingly so over the next 5 years, projected to exceed $10 billion. Specifically, the types of companies and partners that are looking to purchase and utilize these materials are power electronics makers, foundries, hyperscalers, and defense primes. And we're already working with some of them as our qualification partners and validators. Folks like SpaceX, national labs, universities, the Navy, and NVIDIA. But none of this would be possible if it wasn't for a team who already knew how to build and ship really, really hard things. Whether that's reusable rockets at SpaceX, leading edge AI models at OpenAI, creating autonomous fighter jets at Anduril, or taking an entirely new class of semiconductor materials from lab to fab for mass manufacturing of record-breaking solar cells. So we know we have a lot to do. This isn't sci-fi, though, and I'm very excited to share that we are just weeks away from our very first launch of our first fab ship, which is our reusable autonomous manufacturing pod. These pods are what are going to enable us to be able to scale and begin our efforts and progress to achieve these gallium nitride wafers and be able to deliver them to market. So with that, I'm very excited to be here today, and we will have much more to share in the future, and this is the way. Thank you.